Organic chemistry questions from May June 2018 session. Okay, question 6 is organic chemistry question. The first one, the table shows a structure of 4 hydrocarbons. Why are the compound P, Q, R, and S known as a hydrocarbon? So what is the definition of a hydrocarbon? As you can see, all of them contain carbon and hydrogen. So a compound known as a hydrocarbon when it contains carbon and hydrogen only. So answer here is actually a definition of a hydrocarbon, which means the compound contains carbon and hydrogen only. That's why we call them as hydrocarbons. Compound P is saturated. What is meant by the term saturated? So a hydrocarbon we divide into two classes. One is called saturated, another one is unsaturated. In terms of hydrocarbon, what is the meaning of saturated hydrocarbon? Saturated hydrocarbon means it contains carbon-carbon single bond. And unsaturated hydrocarbon means it contains carbon-carbon double bond. So why we call compound P as a saturated hydrocarbon? Because it contains carbon-carbon single bond. If the same question was there and they asked why Q, R, and S are unsaturated hydrocarbons, so we'll say because they contain carbon-carbon double bond. So the type of the bond change the nature of a organic hydrocarbon. If single bond saturated, double bond unsaturated. Compound P undergo a substitution reaction. What is the definition of a substitution reaction? So definition of a substitution reaction when element when atom or group of atom replaced by another atom or group of atom, we call substitution. So what happened? The definition of a substitution reaction when one atom replace the other atom from the compound, we call that as substitution reaction. This is the definition. State the condition for this reaction. So P is saturated hydrocarbon or P is alkane. And what condition alkane react with chlorine? So what are the reaction conditions for a substitution reaction when alkane plus chlorine? So the reaction conditions when any alkane react with chlorine, we should have a UV light or ultraviolet light, or even it is acceptable sunlight. So you can say UV, ultraviolet radiation, or you can say sunlight. Both are correct. Then write a chemical equation for this reaction. So how to write a chemical equation? First, you have to identify what is compound P. Compound P contains 2 carbon and 6 hydrogen, so it is ethane. So we have to write a a chemical equation for ethane. So ethane is C2H6, 2 carbon, 6 hydrogen, and it reacted with chlorine. So in substitution reaction with alkane, what will happen? One chlorine take position of hydrogen, and one hydrogen will take position of a chlorine. So what will be the product? We already have 2 carbon atoms, so it will remain 2 carbon. Out of 6, one of the hydrogen is replaced by chlorine, so we're left with 5 hydrogen, and there is 1 chlorine added. Plus, what will always be a second product, because 1 chlorine is left here and 1 hydrogen go out, so it will combine with each other. As a result, it will produce HCl. So ethane plus chlorine will produce chloroethane plus hydrogen chloride. So this is always the case when substitution reaction occur in alkane. One atom replaces the other atom. Then compound R undergoes an addition reaction. So compound R, what is compound R? This is compound R, which is 1, 2, 3 carbons of propene. So what is the definition of addition reaction? when atoms, like different types of atoms, combine and form only one product, we call that reaction as addition reaction. So addition reaction means like we have more reactants produced, or many reactants instead of more, only one product. So that is known as addition reaction. Then a compound containing bromine is formed in this reaction. Draw the structure of this compound. So R undergo addition reaction. So we have to, R is propene. This is R, compound R, which is propene. So when propene reacts, it will undergo an addition reaction. So what will be the product? For example, this is CH2, double bond, CH, and then CH3. And it reacted with bromine. Bromine is Br2. So what will happen? One bromine added to the first carbon, which is having a double bond, and the second bromine added to a second carbon, which is having a double bond. The double bond will break. It turned into a single bond, and we have to represent all the atoms and all the bond, all the atoms and all the bonds. So this will be, this bond, double bond will turn into single bond. It's already having two hydrogen. So one hydrogen here, example, one here. So one bromine is added. So this bromine is added to the first one. And the second one is having a hydrogen and a bromine is added. So there will be a bromine. And then the last one is already having three hydrogens. So there is no change. And it is up to you. You can make like both bromines up and hydrogen down, or both bromine down, hydrogen up, or adjacent. So it does not make difference. So this is a product which is formed when a bromine react with propene. So always remember, the double bond will break and one bromine added to the first one, which is having a double bond, and the second bromine added to a second carbon, which is having a double bond. So the product which is formed here, which is having now a single bond and a bromine is added. So this is bromine and this one is also bromine. Then draw the structure of unbranched isomer of compound S and show all the bonds and all the atoms. For S, you have to identify what is compound S. Compound S is 4 carbon and first carbon is having a double bond, so it is butene. And remember, whenever we want to draw an isomer of alkene, how we can draw? There are different ways to draw an isomer. What we can do, first thing, we can change the position of a double bond. Second thing, what we can do, we can make a cyclic alkane. And the third one, what we can do, we can make branch. But try to avoid making a branches for, especially for alkenes, because sometimes you have to name them. So it's better draw, like first try to make different position of a double bond and then make a cyclic. So we have a compound S, which is butene. And we want to draw an isomer of this compound. So double bond is present with the first carbon, like 1, 2, 3, 4. So it is present between the first and the second carbon. What we'll do, we'll change the position of a double bond between the second and the third carbon. So the compound, 4 carbon atoms will be there. So there are 4 carbon atoms, 1, 2, 3, 4. And the first 2 carbon atoms, second and third carbon atoms will have a double bond. Then, because it's a hydrocarbon, so this will have 3 hydrogens. This will have 1 hydrogen only. This will have 1 hydrogen, and the last one will have 3 hydrogens. And what is the name of this compound? Because there are 4 carbon atoms, so for 4 carbon atoms, it will be bute. But because the double bond is with the second carbon, so it is bute to ene. So bute, because of 4 carbon, 2 is the position of a double bond, and ene is representing a double bond. Compound Q undergo a polymerization. So compound Q undergo a polymerization. Remember, whenever we have a carbon-carbon double bond, alkenes are there. What kind of polymerization they can undergo? They will always undergo addition polymerization. And for condensation polymerization, either it will be alcohol, carboxylic acid, or amine to undergo a condensation polymerization. But whenever there is a carbon-carbon double bond, it will always undergo an addition polymerization. So name the polymer form. The name of the polymer is always after the monomer. So compound Q contains 2 carbon atoms. So that is why it is Eth, and they have a double bond ethene. So if they react and form a polymer, the polymers are named after the monomer. So name of the polymer will be polyethene. E and E will be there, even though the polymer does not contain a carbon-carbon double bond, but we always name the addition polymer after the monomer. That's why if monomer is ethene, the polymer will be polyethene. So the name of the monomer here, the polymer, that is polyethene. And then complete a chemical equation for polymerization. So during a polymerization, the double bond will break. The double bond will turn into single bond. And the molecule will continue. And we'll put a bracket and N. N means like it will continue till the nth molecule. So this is a monomer which is having a double bond, and the polymer will not have a double bond, and it will have a carbon-carbon link as a result of breaking down the double bond. Then amino acids or amino acids form a protein. So remember, what is the difference between a nylon and a protein? In a nylon, if it was example a nylon, it will have both side one molecule, both side amine group will be there, another molecule, both side carboxylic group will be there. But if it is a protein, one side they have amine group, another side carboxylic. One side amine group, other side carboxylic. One side amine group, other side carboxylic, and they are linked with each other. So this is and this linkage or a bond, what we call that as a amide or a peptide linkage. So if there was a same question and they ask complete a structure for a nylon, so how to complete a structure of a nylon? So you have to draw identical groups, like this is amine, so this will also be amine. One molecule, both side amine, one molecule, both side C double bonded with O. And the other molecule, both side amine, and then C double bonded with O. And we link them together to form a nylon. But if it is a protein, then one side amine of the molecule, other side carboxylic acid. The structure shows an ester. Write a word equation. So how to write a word equation for ester? First, you have to name this ester. So what is the name of ester? The part which is attached with oxygen, we name first, and that is always with YL, and the part which is attached with C double bonded with O, we name it second, and that is always with OA. So what is the name of this ester? The name of this ester, 2 carbon atoms. So ethyl. So this is ethyl, the first one, and then 4 carbon atoms, including this one, 1, 2, 3, 4. So it is bute and OH. So it is ethyl butanoate. And ethyl butanoate is an ester. So first part of ester is always from alcohol. So which alcohol is there? That is ethanol. And which acid? The second name is always from the acid. So it means butanoic acid. So the word equation for formation of this ethyl butanoate, first we identify the type of ester. So it is ethyl butanoate. The first name is from alcohol and the second name from acid. So the word equation is ethanol mixed with, so if we have ethanol which is mixed with butanoic acid, this gives ethyl butanoate plus water will be there as a product. And the reaction is reversible. The reactant can form a product like ethanol plus butanoic acid can form ethyl butanoate plus water. The forward reaction is known as esterification and the reverse reaction is known as hydrolysis, like breaking down of the molecule into alcohol and carboxylic acid. So the forward is esterification and the reverse is hydrolysis. And for hydrolysis, you have to learn the reaction condition. We need sulfuric acid, H2SO4. H2SO4 is used as a catalyst for this reaction to occur.